In section 3, we're going to talk about rectangles, squares, and rhombi. So let's start with rectangles. So a rectangle is a parallelogram with 4 right angles, which means that a rectangle has all of the same properties as a parallelogram, except for the fact that all of its angles are right angles. So we have 2 theorems based on parallelograms. On rectangles. The first is that a parallelogram is a rectangle if and only if its diagonals are congruent. So not only do they bisect each other, but they're congruent to start with. And secondly, a quadrilateral is a rectangle if and only if it has 4 right angles. So it's pretty similar to the definition, but the definition is based on a parallelogram. This is the generalized version of a quadrilateral. So in our picture here, we have a rectangle. All of its angles are right angles. Because it's a parallelogram, opposite sides are congruent. And then not only are the diagonals congruent, but they also bisect each other, which means all of our pieces of our diagonals are congruent. Let's take a look at some examples. So we have our rectangle ABCD. We want to find the measures of all of its sides, diagonals, and angles. So opposite sides are congruent. So I know that AD is going to be 7 inches as well, because it's opposite of CB. We also know that AB is going to be 4 inches, because it is opposite of CD. When it comes to diagonals, all of them are congruent, which means that BD has to equal 10 inches. It also means that AC equals 10 inches as well. When it comes to finding our missing angles, we know that angle ABD is 50 degrees. And because all of the angles in a rectangle are 90 degrees, that means that the angle CBD has to be 40 degrees. We're going to also go ahead and find the measures of all of our other angles, and I'm just going to use some congruent arcs to label which ones are congruent. So we can think AD and CB are parallel sides, which means we can think of BD as the transversal, which means angle ADE is alternate interior, which means it has the same measure as CBD. Would also mean that angle CDB would have to then measure 50 degrees. Similarly, triangle BEC is going to be an isosceles triangle because it has 2 pairs of congruent sides, which means the base angles are congruent, which means angle ECB is going to be 40 degrees as well, which means angle ECD is going to be our 50-degree angle. Going along the same pattern, AEB is a isosceles triangle, which means angle AEB is 50 degrees, which would then make our angle DAE our 40-degree angle. So lots of opposite angles being congruent, lots of isosceles triangles in our rectangle. Next, we have that RECT is a rectangle. We know that RA is 43x and AC is 214x minus 742. We want to find ET to the nearest tenth. So RA and AC are parts of the same diagonal, so they are congruent to each other. So to solve for x, we know that 43x is going to equal 214x minus 742. First thing we're going to do is subtract 214x from both sides. we end up with negative 171x equals negative 742. We're then going to divide both sides by negative 171, and we get that x equals about 4.3. It's a decimal, but because we want to find ET to the nearest tenth, we're going to solve for x to the nearest tenth as well. So ET is the length of our other diagonal. Because the diagonals are congruent, it's the same length as RC, which is which is RA and AC added together, which is basically saying one of them times 2. So if I want to find ET, I can take one of my diagonals, such as 43x, and multiply it by 2 to solve for ET. So I'm doing 2 times 43 times 4.3. So plugging that into a calculator, we get that ET has a length of 373.2 to the nearest tenth. Our next example says, in order for ABCD to be a rectangle, what must be the value of x? So we have 2x plus 6 and 42. In a rectangle, all angles are right angles, which means that when I add 2x plus 6 and 42, I have to get 90 degrees in order for it to be a rectangle. So combining my like terms, we end up with 2x plus 48 equals 90. We're going to subtract 48 from both sides. So we get that 2x equals 42. Divide both sides by 2, and x has to equal 21. Next, we're going to use the diagram as well, along with the information that AE equals 8 to solve for some values and side lengths. So we know that AE is 8. Remember, diagonals are congruent and bisect each other, which means those are all congruent to each other, which means AC, which is my entire diagonal, is going to be 2 times 8, which means it's going to be 16. BE, which is a piece of diagonal BD, is congruent to AE, which means it has a length of 8. ED, the other half of diagonal BD, will also have a length of 8, which means my entire diagonal BD is 8 plus 8, which gives me 16. Next, we want to find the measure of angle EDC. So using information about which angles are congruent based on our diagonals and alternate interior angles, our angle EDC is congruent to the 2x plus 6. So I just have to plug in x to figure out the measure of angle EDC. So we're going to do 2 times 21 plus 6. 2 times 21 is 42. 42 plus 6 is 48, which means EDC is 48 degrees. Go ahead and label that in my diagram. The last angle we want to find is the measure of angle DEC. Which is this angle. Using what we know about the triangle DEC being isosceles, we know that angle DCE is going to be congruent to angle EDC, which means they're both 48 degrees. So in order to find the remaining angle in that triangle, we're going to do 180 minus 48 minus 48, which means that we get 84 degrees as the measure of our angle DEC. Next, we're going to talk about a rhombus. And a rhombus is a parallelogram with 4 congruent sides. So again, because it is a parallelogram, it has all of the same properties as a parallelogram, with the additional property that all of its sides are congruent. So we have 3 theorems that have to deal with a rhombus. The first being that a parallelogram is a rhombus if and only if its diagonals are perpendicular. So what that means is not only do the diagonals bisect each other, but when they bisect each other, they form right angles at their intersection. Next, we have that a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So it means that when my diagonals go through the angles, it splits them in half. And then lastly, a quadrilateral is a rhombus if and only if it has four congruent sides. So let's go ahead and label this information in a rhombus. So all 4 sides are congruent. Opposite angles are bisected. They're also congruent because in a parallelogram, opposite angles are congruent. Okay. And lastly, when the diagonals bisect each other, because that is a parallelogram, and that they are perpendicular, which means all of these angles are right angles, which means when diagonals are drawn in a rhombus, it creates 4 right triangles. Lastly, let's talk about a square. So a square is a parallelogram with 4 congruent sides and 4 right angles. And the most important piece of information next here is that a square is both a rhombus and a rectangle. So not only does it have all the properties of a parallelogram, it also has all of the properties of a rhombus and a rectangle. So go ahead and label what we know. All of our sides are congruent. All of our angles are right angles. We also know that the angles formed by the diagonals are right angles as well. We also know that when our diagonals are drawn, they bisect our opposite angles, which means all of these angles are congruent to each other. And because they're bisected, they're more specifically all going to be 45 degrees. Go ahead and label that. We also know that the diagonals are congruent and they bisect each other, which means all of these pieces of our diagonals are congruent as well. Opposite angles are also congruent, but because they're all right angles, doesn't really matter as much as if it were a rhombus. Same thing with a rectangle. The opposite angles are congruent, but they're all right angles. Let's go ahead and take a look at some examples. So we have that ABCD is a rhombus. The measure of angle ADB is 27. We want to find the measure of angle ADC. So labeling our angle, ADB, and then ADC is its entire angle. So DB is our diagonal. It bisects angle ADC, which means the measure of angle ADC is going to equal 2 times the measure of angle ADB. So it's 2 times 27, which means the measure of angle ADC is 54 degrees. Next, we're going to use rhombus PQRS and the given information to find some values. So the first thing we want to do, we know that SQ is 24, RP is 10. We want to find the length of SR. So SR is this side of our rhombus. We're going to use the fact that STR is a right triangle because we're given the lengths of the diagonals. The diagonals are bisected, which means they are split in half. So if SQ is 24, ST is 12, and if RP is 10, it means that RT is 5. So in order to find SR, the missing side of a right triangle, we're going to use the Pythagorean theorem. So we have that 12 squared plus 5 squared is going to equal SR squared. 12 squared is 144 plus 5 squared, which is 25. 144 plus 25 is 169. Then we take the square root of both sides and we get that SR is 13. Next we have that the measure of angle PRS is 17, and we want to find the measure of angle QRS. So PRS is right here. It has a measure 17 degrees. QRS is its entire angle, and again, the angles are bisected by the diagonals, which means the measure of angle QRS is twice the measure of angle PRS, which means it's 2 times 17. So the measure of angle QRS is 34 degrees. Next, we want to find the measure of angle STR. So STR, we've already labeled it, is one of the angles of our diagonals. And because diagonals are perpendicular, it means they're all 90 degrees, so the measure of angle STR is 90 degrees. Lastly, we know that SP is 4x minus 3 and PQ is 18 plus x. We want to find the value of x. So SP and PQ are two of our sides, and in a rhombus, all of our sides are congruent, which means in order to find the value of x, I take 4x minus 3 and set it equal to 18 plus x. I'm going to subtract x from both sides, so we get 3x minus 3 equals 18. Next, I'm going to add 3 to both sides, and we get 3x equals 21. Divide both sides by 3, and then we get that x is 7. Next, I'm going to look at some examples involving squares. So ABCD is a square. The measure of angle DBC is 5x minus 5. We want to find x. So all of our angles are right angles, and our diagonal DB bisects that angle, which means that the measure of angle DBC is 45. So in order to solve for x, we're going to take 5x minus 5 and set it equal to 45. We're going to add 5 to both sides. So we get that 5x equals 50. Divide both sides by 5. And we get that x equals 10. Our last example, we have our square ABCD with AB equal to 5x plus 4, DC equal to 3x plus 8, and DB equal to 2x minus 1. We want to find the lengths of all sides and diagonals of our square. So let's first start by solving for x. AB and CD are two of our four sides. and all of our sides are congruent. So in order to solve for x, we're going to set 5x plus 4 equal to 3x plus 8. Subtract 3x from both sides. Get 2x plus 4 equals 8. Subtract 4 from both sides. We get 2x equals 4. Divide both sides by 2, and we get that x equals 2. So the first thing I'm going to find is the lengths of all of our sides. So all of our sides are the same because it's a square. So that means that AB equals BC equals DC, which equals AD. And I just have to plug x into one of our lengths. And I'm going to do the 5x plus 4. So 5 times 2 plus 4. 5 times 2 is 10, which means AB, BC, DC, and AD all have a length of 14. Next, we want to find the lengths of our diagonals. And even though our second diagonal isn't drawn, it's going to be the diagonal AC. And in a square, the diagonals are congruent, which BC equals, BD equals AC, which has a length of 2x minus 1, so it's going to be 2 times 2 minus 1, which is going to be 4 minus 1, which means that BD equals AC equals 3. So I know we talked about 3 shapes in this section, a rectangle, a rhombus, and a square, but they have a lot of similar properties. So if you have any questions when you're working on the assignment, please let me know.